I'm going to talk to you about planetary biodiversity and how it's important for saving our environment. So just stand by, because I actually need your help on this one, and I really mean that. When Kennedy wrote this quote, I don't think he knew how absolutely profound it was. He certainly didn't know it in 61, because we didn't know it in 61. So I want to step you through this and pause. I believe that everything we need exists on this planet for our survival. Now, how do you play from there? You got to look where you've never looked before. Because if you looked where you have looked before, you'll find what you've always found. So we want to change that, right? We want to switch the narrative and look in a different place. So you got to go deeper. You got to stay longer. You got to figure out the next place that you got to look. So with that, I continue to explore for life. And this exploring for life is not just about the life of our planet, which is certainly important and absolutely viable. We need to make that work. But it's the life of what we're going to hand to our next generation, to the 18 to 25-year-old range that we have right here, right? We want to hand something good to them, or at least better than we got. I know it's hard, but we're working on it. So I retired from the Navy after 28 years of active duty service, and when I did, I was a submersible expert. So I got a call. I built dry combat submersible for U.S. Special Operations Command, so I was an underwater guy and a submersible guy. I get a call from James Cameron's people. Said, hey, Jim wants you to come out to the house. I'm like, Jim who? Like, James Cameron. I'm like, oh, yeah, sure, send me a ticket, right? So I go out to his house, walking his dog on the beach, no kidding, right? And we're talking about this submersible that he's in right here. And you think about this and you go, this guy who has no marine science education, none whatsoever, he goes to the bottom of the Marianas Trench. Why? Because he said, I got a good idea. I'm going to look where nobody's ever looked before. Okay, sure. Well, certainly he goes to the bottom of the Marianas Trench, and when he does, he finds a sea lice. Now, that sea lice that you see pictured there, basically, in Florida, the sea lice are really small, teeny tiny, nitinoid little creatures, and they bite you underneath your wetsuit, but you really almost can't see them. This picture, they're obviously huge. He had no idea what he was looking for, but he grappled it and brought it to the surface. Now, I'm there, and I'm writing a report on the valuation of this submersible, what it's worth, what's its intrinsic value to our planet, right? That's my job, is to write that report. December 24th, 2012, don't ask, it's James Cameron, and it had to be due on Christmas Day. I don't know. So I'm writing the report, I'm in my office, and I'm looking at the reports. I asked them to pull a DNA sample on this. When they pulled the DNA sample on this particular sea lice, it's a partial cure for Alzheimer's. Wait, pause. Go back. I'm going to say that again a different way. It's a partial cure for a disease that afflicts humanity that was living at 35,000 feet for God knows how long, that we never knew about because we never looked there. So if you look where you've always looked, you'll find what you always found. You have to look in that different place. So like we said, everything exists on this planet that we need. I certainly believe that. So what did I do? I put my money where my mouth is. As I was sitting in the chair, hands behind my head, thinking, we got to live in the water. And everybody's like, he's lost it. He's insane, right? I'm like, no, we got to live in the ocean because, you know, when you live there, you can actually find things more. So I planned this mission to live underwater for 100 days. And I did that at Jules Undersea Lodge. And basically, I brought a bunch of high school kids in, and we did a whole bunch of science, technology, engineering, and mathematics. So it had three parts to it. First part was, I have a PhD in biomedical engineering, and I wanted to know what happens to a human being when you leave them in an isolated, confined, extreme environment for 100 days. Well, that's kind of akin to, you know, space travel. Okay, so we did blood, urine, saliva, electrocardiograms, electroencephalograms, real hard science that hasn't been done since the days of C-Lab. Second thing was science, technology, engineering, and mathematics. I wanted to make sure that young people, 18 to 25-year-olds, said, hey, listen, science could be cool. It's not about beakers and microscopes and lab coats and, I'm bored already, right? It's not just about that. You can do science in a really cool environment, and it can be fun. And the third and final thing is, I got to talk to the greatest people on the planet. PhDs, MDs in everything from coral research to sponge research to microbiology people to astronauts, and talk to them about all these problems. And then back share with people in the science, technology, engineering, and math so that the kids did understand that we were doing some cool things. And I learned that not only are we talking about preservation and protection of the marine environment, we're talking about now rejuvenating our marine environment, which is great for all of us. So like I said, money where my mouth was, we just went out and we looked underwater. So here we are in this place where thousands of people have dived. And I mean, literally, I absolutely wasn't the first person that went down on a dive in this place. All I did was swim out, got a little sample off the bottom, and I had a microscope underwater, right? The underwater classroom. So I'm looking at this little piece of dirt, speck of something. It turns out to be a new single-celled psyllid, or single-celled organism, right? New to science. Nobody's ever seen it before. Why? Because I looked where nobody's ever looked before. All right, so what you see here is the origin of species. We believe right now that everything came from the coelacanth. You came from the coelacanth. Your dog came from the coelacanth. The dinosaurs came from the coelacanth, right? So everything and everybody on this planet came from one thing and mutated. Okay, great. Well, if that's the case, you could understand that if something mutated a disease, something else mutated a cure. And we have that one proof, right? So there's at least one thing that we know for sure is proof. Well, hold on a second. Let's talk that through. So the fish that you see swimming around, they have antifreeze running through their veins. They swim in 30-degree water all the time. Why did we go and invent this toxic substance called antifreeze when we could have definitely used something like this or learned from our kin? They also swim around with these things called cap. And these caps are nothing more than peptides that have strong antibiotic properties, so we can use them as antibiotics. The sea sponges that you see up here, these sponges, a powerful antiviral called acyclovir is derived from the sponge. Why? Because it stays in place and it has to filter feed as the water goes by it. It can't just get up and run away from its stuff. So it has to stay there. So it makes an antiviral in and of itself, right? There are great things like barnacles stick really, really well. Why did we invent superglue, which is, so toxic, right? The sea skirts have anti-cancer causing properties. I mean, there are so many lessons that we can learn from new species that we find in the ocean. So in 4.5 billion years of genomic wisdom, we've come to one startling truth, that there are between 10 and 30 million species on this planet. That means things. There are 10 to 30 million things on this planet. Now, some of them are in the rainforest, of course, right? Some of them are flying around, of course, but a large portion of them are in the water. Why? Because we're 70% water, for crying out loud, right? So we believe that we have found, we don't believe, we have found and described about 5 million of these species. Well, that's pretty good, but what's the problem with that? We're on the precipice of the 6th great extinction, right? So we're coming up on another extinction, and let's just say that the cure for cancer was in the Triceratops. Well, the Triceratops is gone. We don't have that anymore. It's extinct. So we can't pull the DNA sample off it, then we can't match it, and we can't help ourselves or our planet, right? So the problem is we're dropping faster than we're actually learning. So we need to do something vastly different right here, right now. This is where I need your help. All right, so in life, boy, follow the money. The money will tell you where your priorities are. And even if they're not your priorities, they are your priorities because this is the way you voted in some way, shape, or form. So I would say that the National Science Foundation Planetary Biodiversity Index gets $4 million. This is a single-year project. This is a great project. $4 million, real money, right? I mean, $4 million, that's good money for me, for sure. This was a 10-year project, so total on that was $40 million. Well, compare that to the National Science Foundation Division of Environmental Biology budget. That budget's $195 million. Now that's real money, right? And we're talking real money specifically set aside to do science. But look, in stark comparison, a single space shuttle launch, $609 million. Now, I don't want you to get the wrong idea. I literally want to be an astronaut when I grow up, right? So I still got just a little bit of time. So much so that I have my space shuttle socks on, right? We're not playing here. So, but I do love space. I see a disparity here between science and going to space. So let's take that another order of magnitude further and go to the National Science Foundation entire budget, $9.87 billion. Let's call it $10 billion for rounding error. $10 billion. Wow, that's real money to do real science with, right? I mean, that's not that piddly little 4 million thing that we first started with, right? We're talking about $10 billion. Well, what's NASA's annual budget? Oh boy, $24 billion. Again, I'm not against going to space. However, I see a disparity. What else? Let's go to the next order of magnitude and look for the entire space shuttle program. The entire space shuttle program was almost $200 billion. Now look, we went up and we reused that plane ridiculously. So it's worthwhile, but $200 billion, stark contrast, right? Overall, the entire International Space Station budget, we're talking $203 billion. The Apollo mission, $207 billion, and incidentally, the Apollo mission, which got 12 men to land on the moon and return safely to Earth, huge undertaking, right? 4.6% of the gross domestic product of the United States of America in that time. Holy mackerel. Like, we are spending trillions of dollars in space. Look at the money, right? In stark contrast to all that, this is what we spend in national defense budget annually. $842 billion, right? Now, I was a military guy for 28 years, and I served this country, and I am all about the military. It is not about that. It's about that figure is disparaging to anything in environmental biology whatsoever. So you just have to follow the money. You just have to look where it's going. So what did we get for trillions of dollars in space? Approximately 656 people have gone up into space. 12 men have orbited the moon. Very few have actually gone into real space. And when I say real space, we're talking about you being very, very close to the Earth. 250 miles is the International Space Station. That's really just a bump on a log, really. The people who've gone there are the people that are a million miles away and done the Hubble Space Telescope and so forth, the Webb Space Telescope, and the ones that have gone to the moon. Those are the real people that have truly been in space. But the rest of them have been in low Earth orbit, which is kind of sort of great, but 656 people or so, right? Now they're going to launch, or they're supposed to launch this weekend, so that number might be off. In contrast, stark contrast, 2 people went to the bottom of the Marianas Trench in 1960. One, my friend James Cameron, went in 2012. And then the total of 28 people, 25 more have gone from 2012 to now. That's it, to the bottom of our oceans. So it's hard. We don't have the capacity to get there. But it's not harder than the defense budget or the trillions of dollars that we've spent in space. So I love Elon Musk, right? He's like, we're going to Mars. We're going, come on. I'm like, I have a question. What are we going to eat? What are we going to drink? What are we going to do with all that muscle loss when we get on the space station and we go around for how long? So why did I stay underwater for 100 days? Well, the answer is because I couldn't afford 200 days, and that's the truth, right? But 200 days is the length of time that it's going to take you to get from here to Mars. That's just to get there. Now, I have another question, Elon. Who's going to carry us off of our plane, whatever it is that we're going to take there? Who's going to carry us off? Because look at the people that come off the International Space Station. They have to be carried away. Why? Disuse. Their muscles have basically decayed. They're not using them. So if you don't work those muscles, and how are we going to work those muscles? You got to figure something out, right? We have to be able to walk when we get on that planet to explore for life. It's really kind of an interesting thing. But I will tell you this. Those who don't know history are doomed to repeat it. Let me pause and take you back in time and tell you about the history of the world. 2.4 billion years ago, cyanobacteria started multiplying like crazy. Now they do this cool thing called photosynthesis, and they produce oxygen, which is great. So this oxygen started to form our atmosphere 2.4 billion years ago. You know what happened 2.4 billion years ago as well? Mars had an atmosphere, and they lost it. Why are we going backwards in time to look at a planet that lost its atmosphere right around the time that we got ours? It doesn't make any sense. We are looking outward. Look, the stars are pretty. Let's look at the stars. But we better start looking here because our world's on fire, and we need to solve it. Does anybody know what this is? Library of Congress. So this is a Library of Congress. Shame on you if you didn't know. Library of Congress. And this stores some really great original things, right? You could imagine that there's probably an original copy of the Federalist Papers, right? There's probably something handwritten by, Benjamin Franklin. There's definitely the President's Book of Secrets, right? I mean, there's a whole bunch of first-round things that are in there that are nowhere else to be had. Imagine this library is on fire, much akin to our world right this moment. Now, it's not all doom and gloom because we can put fires out. But what I want to do is I want to use you guys. And I'm going to go halfway. I'm going to go from you this way. And I'm going to say, okay, I want you guys all to grab the fire hoses, grab the buckets, run in there, and start squirting out the fire. But you guys from here over, I want you to run into this library and grab a couple of the great books off the shelf, some of the great works, any of the original stuff, and bring it out here where it's safe, that analogous to our world is on fire, for you to have and catalog all of the species. So we have between 10 and 30 million things on this planet. Each one of them has a story. This is the greatest library on earth, and we need to save it. The good news is we have a good handle on trying to do that. So I'll tell you this. This is me in like 69 on the far left. Think about the science that we knew in 1969. We certainly knew the world was round. We knew a couple of really good things. However, we didn't know as much science as we did. Now, that's me when I was 18 years old in the middle, and that's me when I was 25 years old far on the right. So that's the average age, right, between 18 and 25 years old in this audience. The good news is that the science keeps going. The more we learn more about things, and we will push our boundaries. That knowledge will compel us to change our minds and move in a different direction. So there's the play, right? It's the take what you've learned and move forward. Change your mind. Let it inform your decision about the next steps that you have to do. Because like I said, Kennedy did not know how profound this statement was. Moreover, how damning it was when he said right after this, I got a good idea, let's go to the moon. And I'm like, but do you remember this other thing you said, like the ocean thing? Yeah, but we're going to the moon. Like, okay, all right, great. But it's great. It's great to have leadership. It's great to have that kind of a thing. But our very life may depend upon our ability to explore the ocean. Moreover, it's all about handing the next world to the next generation and continue exploring for life. So with that, thank you very much.